Hello everyone, and welcome to this second tutorial on XFLR5. Today we're going to be looking at other important aspects of XFLR5's direct airfoil analysis. I have chosen this Whitcomb integral supercritical airfoil for today's analysis. I have downloaded the airfoil data to my computer. Let's go ahead and start. Okay, so this is the starting screen of XFLR5. To open up your airfoil data, you should go to File and Open and choose your airfoil data. This is our airfoil loaded up from the data file. So as you can see, we're immediately in XFoil's direct analysis menu, so we don't have to choose that. So the first step after loading up our airfoil is to go to Design and Refine Globally. I'm gonna choose 300 panels. So this airfoil has about 11% thickness. For thinner airfoil, you might have to change the density parameters, especially around the leading edge and the trailing edge, and of course the number of panels to get a converged result out of this software. So just keep that in mind. For thinner airfoil, you might have a more difficult time than for airfoils with higher thickness. You might have a more difficult time in getting converged results. So I'm gonna go ahead and refine my airfoil, hit save, choose a name and save your airfoil. So here is my airfoil. Now I'm gonna go ahead and define an analysis. We're gonna use a type 1 analysis. Choose a name for your analysis, choose your Reynolds number. I'm gonna use a Reynolds number of 3 million and add a MECH number of 0, and I'm gonna leave the transition settings as default. Hit OK. Now I can go ahead and choose alpha for my, or the angle of attack for my sweep. I'm gonna check this sequence checkbox. An important thing here is that in XFLR5 it's better to always start your sequence of analysis from 0 to, if it's either positive angles of attack or negative, always it's better to start from 0 to a positive angle of attack and then another sweep from 0 to a negative angle of attack. So I'm gonna start my analysis at 0 to 23 degrees with increments of 0.1 degrees and hit analyze. Okay, so now that our analysis is over, for the positive angles, I'm gonna choose a sweep into negative angles as well. So from 0 to minus 10 degrees. Okay, so now we can have a look at our results. So at 0 angle of attack, we have this distribution of pressure coefficient over our chord. So I'm gonna change my angle of attack slowly. As you can see, angle of attack is increasing and my CP graph is changing as well, and also into the negative angles of attack. So right now what I can do is choose any angle of attack from my analysis result, say 12 degrees, and I'm gonna go ahead and keep in mind that we are in the operating point view. So right now I want to extract the results of this analysis and basically study the raw data. What I'm gonna do is to go to operating points menu. From current operating point, I can go ahead and export the raw data or export the boundary layer data. So right now I'm more interested in the boundary layer data, so I'm gonna hit export boundary layer data, and you can just choose a name and hit save. And now let's go ahead and have a look at our boundary layer data. Okay, so as you can see here, this is my airfoil, this is my analysis at 12 degrees angle of attack and a Reynolds number of 3 million. So here we can see on the top side of my airfoil, I have my data for different parameters here. So X is the position on the chord of the airfoil, H would be my shape factor. So you can go ahead and choose any of these results and basically generate your own plots in other data analysis software. So right now, if we have a look at CF versus chord location, we can see that CF decreases as we go along the chord, and then right at this point, CF goes from a positive value to a negative value. That means there's a separation point right here. And then further down, we have a change in CF from negative to positive, which means a reattachment point. And you can also look for other reattachment or detachment points. So looking at our bottom side of the airfoil, we can see the same results and analyze our data the same way. Another important view in XFLR5 is the polar view. You can access it here. I'm going to click on Polar's view. Here we have a general overview of all of the results. To quickly browse in these plots, you can hit numbers 1 through 5 on your keyboard and cycle through these 5 plots. So 1, 2, 3, 4, and 5. You can hit T on your keyboard for 2, and you can hit A for all of these plots. You can also double click on any of these plots and choose whichever different parameters to show. Just looking at our CL versus angle of attack plot, we can see that our airfoil goes into stall at about 17.7 degrees angle of attack. You can also export these plots to have a more accurate look into the raw data and maybe use other data analysis software to draw and generate your own plots. To do that, you can go ahead into Polar's menu, and then from current polar you can export our current polar. You can choose a name and hit save. Now let's go ahead and have a look. Okay, so here is our current polar of our analysis. Basically, we can see here our Reynolds number and MECH number are fixed. We can see different transition parameters and our Reynolds number. So again, we have different parameters to look at, starting with the angle of attack. At different angles of attack, we have different parameters, including lift coefficient, drag coefficient, and transition points on the top and bottom surface of our airfoil. And that's it for our second video tutorial on XFLR5. Hopefully you guys can find these helpful as well.